In this lesson, we will focus on cognition, or thinking, and problem solving. Let's start with the definition of cognition, which we've covered before in previous lessons. This refers to your higher mental processes. It involves thinking, knowing, language, memory, learning, communicating. This next term, concept, we have seen before in a previous chapter. It was called a schema in the chapter on developmental psychology. Both refer to a category or folder that we group similar information into. For example, we have schemas or concepts or categories for fruit or holidays or tools, even school supplies. If I said name some school supplies, you might say pens, pencils, notebooks, scissors, binders. All of those would be objects that you would fit into a similar category, which we call a concept in this chapter. Before we move on to the next slide, I would like you to try a little activity. I'd like you to draw a mental image. I want you to draw on a piece of paper your mental image of a country singer and a rock star. You can draw with detail, or you can use stick figures. But an onlooker should be able to tell or recognize which is the country singer and which is the rock star. Please pause for a few minutes and draw those. So most of you probably have a cowboy hat on the country singer and either long hair or spiky hair for the rock star, similar to what you see in the slide. Interestingly, most people share the same mental images when it comes to a category, concept, or mental representation. And this is known as your prototype, your best mental image of a particular concept. Take a few seconds and in your mind, imagine a bird. Most of you probably imagined a bird similar to the one that you see on the left. You probably didn't imagine a penguin, even though that is also a bird. So your prototype is your mental image or mental representation of a particular concept, category, folder, or schema. There are two different types of thinking, convergent and divergent. Convergent thinking involves having a problem, and you have to choose the best solution. This is very typical of a multiple choice question. You read the question, there's a problem, and you have 4 options to choose from. You're converging in on the answer. Divergent thinking, on the other hand, takes a little bit more creativity. Here you're posed with a problem that you have to solve, but you have to come up with multiple answers to that solution. This slide represents the 2 types of thinking that an elementary school child might face. First of all, posed with the question, which word rhymes with slice? That will be convergent thinking. Here you have a problem and you have to pick the correct answer from that list. On the other hand, as I said, divergent thinking involves a problem and you have to come up with multiple solutions. So a child may see a question that says, list as many words as you can think of that rhyme with lead. Now I'd like to shift to a few problem-solving strategies. For the first strategy that we're going to cover, I would like you to pause the video and try to figure out this husband and wives riddle. This may take about 5 minutes. If you figured it out, you had to break it down into smaller bits of information. A lot of problems that we are faced with are way too complex to just simply look at or read and solve the problem. It may require dissection or breaking it down into smaller bits of information. So here you have three men, Fred, Ed, and Ted, who are married to Sally, Vicky, and Joan. In order to figure out who is married to who, you had to break down or dissect the information. First of all, Joan and Ed are brother and sister, so they can't be married. Ed weighs more than the man married to Vicky, so they can't be married. Process of elimination says that Ed must be married to Sally. So Fred cannot be married to Sally, and Fred lives in Ann Arbor, and Joan lives in Detroit, so he's probably not married to her. So process of elimination, Fred is married to Vicky. So that leaves Ted. His only option would be Joan, and that is dissection. Again, I would like you to pause the video and try to figure out which number would follow in this sequence. 10, 4, 3, 11, 15. Which of the options, A, B, C, or D, would come next? Most of you were probably trying to add and subtract or multiply and divide to figure out what would come next in this series. And that is because that would be a problem that you've seen before in math class. Whenever we see a series of numbers and we're asked what comes next, we're looking for some mathematical connection that we have conquered in the past. This is known as your mental set. However, this was a trick. First of all, the number 10 has 3 letters. Number 4 has 4 letters. Number 3 has 5 letters. 11, 6 letters. 15, 7 letters. So 14 would follow. So you should have chosen A, because 14 would have 8 letters. But this is deceiving. As I said, most of us would be looking for some mathematical connection, because that is what we've conquered in the past when seeing something that's similar. So the reason why most of you were looking at trying to make a mathematical connection in the previous slide is because that is something that has worked for us in the past. So this is basically prior knowledge, our tendency to approach a problem in a way that we have been successful in the past is our mental set. See if you can complete the following pattern. O-T-T-F. What 3 letters would come next? Take a minute, pause the video, and see if you can figure it out. The answer would have been F-S-X. F-S-S. 1, 2, 3, 4 from the previous slide, and then 5, 6, 7 to complete it. After having that mental set, that prior knowledge, see if you can fill in what would come next after J, F, M, A. Take a minute and pause and see if you can figure that out. The answer here would be MJJ. May, June, July. So January, February, March, and April are represented. May, June, and July would come next. That should be a little bit easier since you already had that prior experience or mental set with the numbers. This next problem would be very easy because that is something that you have tackled in the past. You're simply just adding a number each time. Once again, I'd like you to pause the videos and see if you can figure out any of the following riddles. These can be pretty difficult, so take about 5 minutes and see if you can solve any of them. I like to watch students reading over those riddles in class, and it never fails. Every once in a while, they'll read it over and over and over again, and then bam, it just hits them, and you can just see that light bulb go off in their mind. That is insight. It is just the sudden realization to some solution of a problem. It just comes to you. So in the previous riddles, number 1 was man overboard. Number 2, a coffin. Number 3, you stand back to back. Number 4, the letter M. And number 5, side by side. The next problem-solving strategy is called an algorithm. You probably use these formulas in math class. It's a method, a logical rule, or a procedure that guarantees that you will solve the problem if you follow it correctly. However, this can be very, very time-consuming. For example, let's say your mother asks you to go to the grocery store to look up a certain sauce, let's say tahini sauce. You've never heard of tahini sauce and you forgot to ask where it would be. You could find it, if it's in the market, by walking down every single aisle and looking on every single shelf. You would be guaranteed that you would find it, but again, very time consuming. Another example, you could perhaps want to find a password for your friend's social networking site. You could use every single letter, symbol, number, combination on the keyboard if you knew how many digits it was. And you could figure that out. However, again, think of how time-consuming that process would be. So an algorithm is a rule or a procedure that if you follow, you're guaranteed to solve it if you follow it correctly, but it may take a very long time to do so. A heuristic, on the other hand, is a faster, more simple thinking strategy. It's kind of like an educated guess or hunch that we try to use when making a decision or trying to solve a problem. If you're able to make this educated guess and solve the problem, it will be much faster. However, it is more error prone. The likelihood is unlikely. So, for example, if you were walking through the supermarket, you may use a heuristic and think, okay, it sounds like sauce. So you might go to the condiment aisle and looking for the tahini sauce. Or you might think it could be Asian or some other ethnic food, and you would go to those ethnic aisles to look for it. If you can find it and figure it out by using that simpler strategy in your mind, it would be a lot faster. But again, more error prone. Another example, in trying to figure out your friend's password, you might try to think of things that are important to them. A lot of people use passwords of their favorite pets or sports teams that they like. So you may try those. Again, if you were able to figure it out, it would be much faster than using an algorithm, but the chances are really unlikely.